So this is the last part before we actually solve for the um, output of the match filter. And just to recap, in the first two videos, we just kind of reviewed kind of like the process of what we would be doing, and then that was what we did in the first video. And in the second video, we reviewed how to write um, S of t in terms of unit steps. And in this video, we're going to actually learn how to find h of t from the graph of S of t and then write it also in terms of unit steps. So um, to get started, h of t we had mentioned was just um, it's the impulse response of the match filter of a filter that is matched to this input signal S of t, and um, actually there is an equation for it, and the equation for it is h of t is equal to S of capital T minus little t. And although we did find the equation for S of t from the graph in the previous video, I highly recommend actually just finding the graph of h of t and writing it in terms of unit steps from inspection of the graph, and not by substituting this capital T minus little t into the S of t equation. And I think the reasons will become apparent as we go through actually solving for the output. The math just gets even crazier than what we'll actually even be doing. So for simplicity's sake, I recommend that we just go through this method, and you can decide which is the best for you. But since we see that h of t is equal to S of capital T minus little t, we can also rewrite that as S of, and I'm just going to open up a bracket, negative. If we factor out the negative, it would be t minus capital T. And the first step in finding h of t would actually be finding S of negative t. And if we were to graph S of negative t, what that would do is we would just plot, it would be a plot of S of t, and it would be inverted across the amplitude axis. So we would have something that has a negative slope, and it would be primarily, we would be looking at this in that quadrant 2 of this xy plane, and it still has an amplitude of a. So this is the graph of S of negative t, and then part 2 would be to add capital T to every point in time across the graph of S of negative t. And what that's going to give us is S of negative t plus capital T. And you can see that if we were to rearrange these terms, that we would get S of capital T minus little t. And so if we were to do that and graph it, what then that would look like is we would just shift everything. So our graph would just shift to the right by t at every point. And so that is what h of t would look like. So h of t really, besides just being the impulse response, we could say that it's a time inverted and time shifted version of S of t. Now to actually determine the impulse response h of t in terms of unit steps, we would just follow the very same logic that we used for finding the equation for S of t. And what we did was we started out by finding what the function is of this line. And that line, if we were to actually find the slope and then plug it into the equation of a line formula, we would find that the function is equal to a minus a over capital T times t. And just as we did previously for s of t, is we are going to multiply this function times a unit step for when it turns on and for when it turns off. And at the time that the function turns on, we're going to add it into our equation, and at the time that the function turns off, we're going to subtract it out of our equation. So since our h of t function turns on at time t is equal to 0, we take this a minus a over capital T times little t, and we multiply it by u of t. And then we do the same thing. Is our function turns off at capital T, so we are going to subtract out our function at time t is equal to capital T, and it would look something like this. So very similar to the s of t process of writing the function in terms of unit steps. And we will just factor it out for simplicity, and we will have a minus a over capital T times little t. And then if we open up a bracket, we would get u of t minus u of t minus big T. And that is equal to h of t. So now we have s of t, we have h of t, and we also know what the equation is for the output of the match filter. And in the next video, we will take a look at solving for the output of the match filter using numerical or analytical convolution. So stand by for actually solving for the output.